Hello, this is Chef Coding. Welcome in another episode of my Erlang tutorial series, and today I will be talking about funs, which are anonymous functions, which means they are functions without names. Okay, so without further ado, let's go. The funs syntax is exactly how I write it here. We are starting with fun keyword. You can save this keyword because you can't bound any variable. And after that, we are putting brackets, just like the normal function. And we can have as many arguments as we like. We can have no arguments, but I will stay with 2 in this fun. After brackets, we are putting the arrow, just like in normal function. Next, there is just a normal function definition. We can put it as many Erlang terms as we like, and the end keyword at the end, right? Okay, but I had a name of this fun, not actually a name. This is just variable, right? It starts with uppercase, so we can bound here some value. And functions are actually thing which can be bounded, but in some different way. Here I am using variable and after that putting brackets, just with some arguments, just like I would do with some function. And yes, it is what it is. We can use anonymous function by bounding it to some variable and then calling its name and putting brackets with argument, just like in normal function. Why would we even want to do that if we have a normal functions and actually we are creating in some way a name for this function, right? Here are the common examples of usage of these funs. Firstly, the list map is function which takes one argument. This should be your list. And here I firstly specify a variable map fun, which is anonymous function fun, which also takes just one element, and doing some operations with that. The last expression in fun is return value of this fun, just like in normal function, right? Here we can pass this fun as argument to some other function. I am calling function map from module lists, and here I am using map fun variable, which is fun, as argument, right? And putting list as the second argument. And what does this function lists map does? It takes this fun and it has to be pretty specified fun because it has to take always just one element. And we are going to go through all of elements of this list and we will be calling this fun for every of these elements. So as you probably can say, this element which is taken as argument for this fun is just an element of this list. And the return value of this fun is the new element which will replace the old element which we took as argument. Let me show you example. Firstly, let's compile. Okay, something is wrong. Why? Yes, now it works. Okay, we got a warning. Export flag enabled. All functions will be exported. It's true. I am using maybe a new attribute, a compile with the atom export underscore all. And this attribute enables us to not export every single function, but by its name, right? How we did it in the previous episodes, but it exports all of them thanks to that attribute. But we will get this warning. But it's okay, our compiling process has ended successful. Okay, so now we can call this list map function. And we'll go with list 1, 2, 5, 5, 6, and 9. And let's see what this fun is doing. This fun is taking every element and multiplying it by 2. And closing this value multiplied by 2 in the one element tuple. That means every element in this list will be a tuple with multiplied previous element inside of it. And that's true. Every element is mapped. That's why this function is called a map. Okay, let's move to list fold function, which I prepared. This function also takes one argument, which is going to be list, and there is some other fun, and this fun takes two elements, element and accumulator. Here's the function fold L from the module lists, so from the same module like map function. And here it also as first argument takes a fun, which also has to be pretty specified. It has to take two elements, and the first argument of this fun is always an element of this list. The second one is accumulator, which can be any value, right? And the return of this fun has to be a new value for this accumulator. We will be calling this fun for every element of this list, and accumulator with every element will be changing, right? The starting value of this accumulator is specified as the second argument of fold L function. And the third one, the last one, argument is a list which we will be folding. And fold L function will go through all the list elements from the left to the right and call this function fold fun for every element. And this function will actually return for us a sum of this list. We can try to do it. List fold, maybe a bit smaller list. Yes, and this will return a 3. Nice. If you want to read more about these functions, which are very, very useful, and it's crucial to know how they work, you can move to official Erlang site, the module lists, and here is the documentation of these functions, the map and the fold L and fold R. And here at the end, I prepared for you some fun facts. And here is the first one. We are in this function, fun fact 1, I'm creating a fun which is adding two arguments bounded to variable add. We can use variables from the outer function, but we can't use the variables from the inner of this fun outside of it, right? So we can't bound here x equal to 2 and use it outside of this fun. We can't do that, but okay, let's back to the previous definition. And in the next fun, I am just calling the previous fun with argument x and 2. And here's the interesting, you can call it a syntax sugar. For me, it's syntax bitter, because we can call the fun in the same place where we defined it. Just after the end, we are putting the brackets, and here we have to put some values which will be passed as arguments to this fun. And you can see it will work. I can put a fun fact 1, and here as argument I will pass 12. So it will be passed as A, and A will be passed to this fun as argument. And we will get 14, just how it should look like. And here is the second and the last fun fact. We can create multiple definitions of the same fun by creating a name, the inner name of the fun in itself. Yes, it's pretty weird, but I'm showing you that we can do that. This works just like a normal function definition. We are separating the another definition by semicolon, but ending by end keyword. It's interesting, and it's not very used very often. It's pretty rare situation to use it, right? I actually can't imagine a problem which will be solved by this syntax. It's pretty awful, so don't mind it really. Just think about it just like as fun fact. Funs are really useful when it comes to higher order functions. This is what actually fold L and map functions are from the module lists, because higher order function means that it takes as argument or returns a function. In this example, we are taking function other function as argument. And that's why lists map and lists fold L and lists fold R are called higher order functions. And yes, now I think it's all about funds. Thank you for watching and see you soon.